Morning, everyone. Welcome to our first MTConnect training session sponsored by AMT. My name is Mike Rogers. I am the chairman of the Education Working Group, which is sponsoring this training this week. I'm joined here by Will Sobel, who's our guest speaker for session one. We have 6 sessions this week. Today is going to be the basics. So we're going to cover intro to MTConnect and the basic configurations for MTConnect and how it works. Tomorrow will be a hands-on 2 sessions with one of our other chairmen, and that will be focused on actually configuring a piece of equipment for MTConnect and what that data really looks like. And we'll wrap it up on Thursday with 2 sessions talking about the features that have been added since MTConnect 1.0 almost 20 years ago to 2.6 where we are today, and maybe a little bit about what's coming for the future. And then also we'll end out the day on Thursday with a session on validation. In other words, how you can actually prove to your vendors that their MTConnect is accurate and is producing data in the format that it should be in order to meet the standard. So, couple little housekeeping things. We do not have microphones or cameras set up for the attendees. We're going to use the chat for any questions. We do want your questions. This session, each of the sessions is going to be about 2 hours long, maybe a little bit later, We've got about 2.5 set up for each one. What we're planning on is about an hour in, we'll take a break, let you guys get a fresh cup of coffee, take care of anything you need to take care of, and then we'll get back into it after about 5 or 10 minutes. We'll also use that interim as a chance to answer any pressing questions or things that we've monitored in the chat that are relevant to where we are in the presentation. And then we'll wrap up the presentation at the end with a full review of your questions and try to get those all answered. So with that, I'm going to introduce Will Sobel, our presenter for the first session. Will has been with the MTConnect group since day one. He's the main architect of this standard. And Will, it's all yours.
Excellent. So let me just get the presentation up here. So yeah, as Mike said, I've been here since day one. I'm going to talk a little bit about the history of MTConnect and go through some of the use cases and give you a brief overview. We're going to get into more detail in the following sessions. So I'm not going to go into a lot of detail about how to use or configure any of that stuff. So we got a lot of content. So let's take it away. So the MTConnect Institute. Let me get on the right window here. Session 1. So the MTConnect Institute is a 501c6, which is a nonprofit. It was set up by AMT after the start of the standard. It is a subsidiary of AMT, so AMT owns it. And for those of you who do not know who AMT is, that's the Association for Manufacturing Technology. They are the trade association for all of the machine tool builders in the US, and they put on the IMTS trade show, if you're not familiar with it. And they run, fund, and manage all the goings on within the larger MTConnect organization. So a little bit about the organization. We don't have an exact number, but from some surveys we've done in the past, we know that we have somewhere on the order of like 150,000 installs globally. We have about 160 members of the standards committee, and there's been tons of work going on into this thing. If you talk about liaisons, we're liaised with many different standards organizations, including like UA, ROS, the ISO TC184 SE4, which is, if you don't know numbers, that is the STEP standards, all of the geometries that you standardize and pass around between CAD applications and other applications. I also work with OHEI, IOF, and QIF is another one. We've actually introduced that one directly into MTConnect. So there's we're very social. So a brief history of MTConnect. It all started back in 2006. AMT invited Dave Patterson from UC Berkeley and Data Edstrom from Sun Microsystems to present at the annual meeting. They wanted an outsider view of what was blocking advanced manufacturing, smart manufacturing in the industry. And what Dave came up with was that they lacked, every machine was an island of automation. It couldn't talk to any other machines on the shop floor. It was basically, nobody knew what was really going on in that machine because you weren't collecting any data. So they said, the first thing you need is to collect data from your machines. To be able to collect data from your machines, you need a standard, or else it's just going to be chaos. So the MTConnect standard was born. Doug Woods, who's now president of AMT, was, I think, chairman of the board at the time, and he approved the project, and basically it was all funded. Paul Warndorf, who is basically the patron saint of MTConnect, the guy who kicked this whole thing off, took control of the project. He was the VP of technology at the time and engaged UC Berkeley to develop the standard. And the idea was, which seemed kind of insane at the time, this is April 2007, was that in 1 year we were going to have everything done and we're going to be able to release at IMTS 2008. So I was working at UC Berkeley at the time, and I got tasked with creating a standard. I had knew nothing about manufacturing at the time, so I basically had to spin up to speed fast. And we wrote the initial version of MTConnect, which is 0.9. At IMTS 2008, the entire ETC, which is the Emerging Technology Center right in the middle of the show, was devoted to MTConnect. And we had 25 machines from around the show live connected to MTConnect with an application that displayed their states and some basic information about the machines. That was, a big deal back then. I mean, now IoT is much more prevalent, but at that time, nobody had done it. So then, right after that, in 2009, we started the MTConnect Institute, and it's been going ever since. That's about 17 years, a little more. And we've been developing the standard, developing open source technologies around it. There's actually quite a bit of technology that's free and available to you to use and to extend and play around with. The Institute itself is the organization that manages the day-to-day of the standard. Things like registering with ANSI, all those kind of fun things, and managing the funding of various people to work on it. We, as the Institute itself, the larger standards body, we are the organization as a standards body that decides on what's going in there, what kind of working groups they have to be voted into existence. The Institute also creates and maintains all the technologies that you'll see demonstrated this week about for the standard, such as the agent, the transpiler, which converts our model into multiple different formats and all those kind of things. And we also, as the Institute, work on some grants and other things to advance the standard. So sometimes for difficult parts of the standard, we need funding to help us get there. So we work with other groups to do that. We have numerous working groups. There is a list of them. Quite a few of these are active. Things like the Executive Committee and the Standards Committee are the two bodies that are called out. The Standards Committee is the larger body of all the participants in the standard. The Executive Committee is a smaller group of people who are basically the leaders of the working groups and a few other invited members. The rest of these basically focus on areas such as machine tool working group focuses on machine tools. We have things like the agent that works on extensions and new technologies that we want to see in the agent. Architecture, that's our modeling group. We have things like robotics, which now focuses on things like inter-device communication, as well as parts and process, which just released the process models. And there's many different focus areas. And if you're interested, please contact us, and we'd love to have you helping out in any of these areas that you have any expertise in. So, general question, why do we exist? The reality is that no shop is ever going to have one type of equipment from one manufacturer using one type of controller. That is just not a reality. So we always end up with this heterogeneous set of equipment that uses different APIs from various different vintages, sometimes going all the way back into the 70s. And we have to get data from those things. So what MTConnect was created to do is to create a common language for how those machines could communicate what they're doing and how they're functioning. So like a dictionary, basically MTConnect provides that dictionary, the language that the machines can speak to express what they're doing. Their statuses, their files, parts. They can talk to other machines. And we have this basically, it's an interface as part of the standard, which just got extended, which basically allows for devices to talk to each other without writing back. So that's a longer discussion we can have later, but pretty much we can do a read-only communication, as well as sensors and a whole bunch of other data that talks about telemetry and various other aspects of the machine. So we standardize the data. Without something like MTConnect, every machine is going to have, if the machine can even speak, it's going to speak using its own terminology and using its own data structure. So the whole idea of MTConnect is it reduces cost. If you think about implementing, if I have, let's say, 5 applications and 3 machines, that's a X by Y multiplier. I have 15 connections that need to be done. Each of those connections to each of those applications requires a custom or a different implementation of that interface. So from a machine tool builder perspective, that means supporting multiple different applications that are out there. And from a customer perspective, that means paying for all of those different connections. It adds complexity, brittleness, and makes your life much more complicated. If anything goes wrong with one of those things, you have to find the right supplier and deal with all that nonsense. So with MTConnect, you only need to, if you even need to pay. I mean, sometimes there is no cost. Basically, MTConnect, if it's already on the machine, we'll go through that later, is effectively a small cost or sometimes even free. And then all the applications can talk to MTConnect. So it concentrates all of these communications you see on the left down to one common vocabulary communication standard. And you save a lot of money. And that was one of the real benefits that MTConnect was created to solve. So we think about the value generation process of data collection. From a raw data perspective, machines and sensors give you basically a raw data. There may be some syntax or structure to it, but effectively it's usually just like tag value pairs or very, very proprietary semantics or syntax. What MTConnect provides is a syntax. It provides the meaning of that data. From the perspective of the device, you can know what axes it has, what the states of the controller are, things like the RPM. The positions are always going to be in millimeters. Load is always going to be in percentage. The rotary velocity is always going to be in RPM. The execution states are going to be locked down for you. So we provide that language here and the structure, the way of organizing all this information for a given device. So when you get down to things like, trying to put it into context around what's happening in the process, it's a lot easier. You only have to deal with this one set of language. So process adds, once you sort of get into the enrichment phase, where you can start to determine more things about the data, because you've integrated it with the business ecosystem. So you can sort of find intervals, start classifying data, match that up with what you expect from the ERP, MES, and PLM systems, with your designs or whatever. Then you can start integrating it into the business system. So this is your integration point. Then you can start, once you get past this point here, you can actually start to make some predictions at the next stage of evolution. And that's where you start to really get some and then you can become agentive. Hearing a lot about that now with AI. These two pieces are now emergent, where when I first did these slides, these were kind of, dreams. I think we're getting to the point now where we're going to start to see some technologies around some more agentive technologies coming out of this. But basically, you can't skip these steps. You have to go through the process of identifying the meaning of the data first before you can get into any kind of enrichment or integration, or you want to get here. Don't skip these steps. You'll be dealing with a lot of pain if you go trying to take your raw data and analyzing it directly. Here's another way of looking at it. As we go, sort of at the pre-standard, we're at the sort of ignorant or no software control. That's, from a process management perspective, we don't know what's going on. Just basically, machines are run by people and people will tell you what's going on. Monitored, basic data collection, and some reports telling you what happened. You can get into real-time analytics next. You can get into, why the process failed, productivity lost. Then you can start getting into predictive, prescriptive. And again, the next level is self-optimizing, getting to the point where your machines can become agentive. Common use cases. We start at the simple, and we'll talk about this more towards the end of this talk, but basic visualization of machine tools, dashboards is kind of where you start with this whole thing. Next, you get into things like notifications. Okay, when something is down for a period of time, send me an email or text. We can do reporting on utilization. Still pretty simple. Just when is the machine running? When is it not running? Maintenance. When is the machine being maintained? When does the machine need to be maintained? Then you get into things like OEE. Was the machine running when it was supposed to be running? How many good parts, bad parts was it creating? Let's see how well the machine was performing, the three pieces of OEE. We can then take it and start bringing it into our MES and ERP solution. So then we're talking about, we know when the machine is scheduled to be run. We know what it's supposed to be doing. Was it doing what it was supposed to be doing? Was it running what it was supposed to be running? Were things like the offsets and the process variables all correctly set? Nobody was doing a feed rate override of 50%. Nobody's putting the machine into a feed hold. Was the part that was created, did it come out correctly? Were there any deviations? Were there any deviations noticed during the manufacturing of the part that weren't picked up until we measured the part? How can we feed that back? Then we get into things like preemptive diagnostics. When will my spindle fail? When am I going to lose tolerance? Is my coolant concentration too high? And then we get into what's called agentive analysis. I'll talk about this a little bit more. This is where you start talking about things like digital twins and MBE and all those kind of fun things. That is where the system can actually suggest or make changes to either what's run on this machine or some of the system settings on the machine to correct errors before they occur. So that's where we're getting into some, of the next gen technologies. Again, we suggest there is a path to that point, but you have to go through the steps, and there's value addition at every single step of this. There's cost, but there's ROI at every single step in every single use case you see here. So let's talk a little bit about, I'm going to start out with what MTConnect is not, because there's a lot of misconceptions about what it is. But let's say what it is not. MTConnect is not a communication protocol. It has a communication protocol, but the communication protocol is not the only way to get information from MTConnect. It is not a document or a representation. So we don't specify that you must use XML, you must use JSON. It can be represented in many different ways. As long as you follow the MTConnect standard, it is correct. And we are coming up with more normative or standardized ways of representing MTConnect. It doesn't serve as a system of record, and it doesn't replace any applications. So, you don't think of this thing as like your ERP, MES, or PLM system. It supports all those systems. It supports systems, record qualities, etc. But it is not an application as such. It is not a data store as such. It is a model, and we'll get into that in a second. And as well, it doesn't compete with any of these other standards, OPC UA, SparkPlug-B, or any of these others that we see there. And just to kind of dive into that a little bit more, just to make sure everybody's clear, you need an application to use MTConnect. And that application can do a multitude of different things. It can be visualization, it could be maintenance, it could be predictive diagnostics, it could be digital twin, any of those things. But it is not an application in and of itself. It needs applications to make it valuable. And one of the things that MTConnect does provide is reference and open source implementations. I'll mention that many times. And we allow people to charge for their solutions if they want to, but the core technologies to MTConnect are free. And what we do provide is the model, data structures, data dictionary, all that stuff, and the behaviors. And the application is responsible for doing something with it. That is different than a lot of other standards out there that produce both the required formats, data structures, and protocols. We do not. And I will hopefully make that clear why we have chosen to go where we have. One of the reasons that we don't standardize just on the documents, basically the PDFs, is because if you ever seen PDFs or standards that just sort of are standardized based on their PDFs, we call normative. The problem is that human language is often imprecise and ambiguous. We need, a lot of times when you use language, we require a human to interpret that language. And we also make this tacit assumption that that person has our training and background and knows everything that we know. So it must be obvious. That is often not the truth. That is not true. Standards provide a domain-specific viewpoint. And the other problem that we run into with documents is that there's no way to automatically validate whether the implementation of the document is correct, because you'd have to parse that document and then make sure that there are no differences with the implementation and there aren't any inconsistencies. Try to translate that document, and things even go worse because sometimes you don't know exactly what the terms mean, and translation always adds another error, a layer of obfuscation. So we have tools actually, and Trey will be demoing them back in number 6. If you're interested, you can stay around for session 6. That translate the document, or translate our model into automatic validation. So we can, with a model, you can do that. With a document, really hard to do. And again, there's maintenance, other issues, and often some of these standards contain acronyms, and we really avoid that in the model. So that, again, it's that assumed domain-specific knowledge. We try to make this easily understood so anybody can consume it. So to what MTConnect is a SysML model. We chose a SysML language because that is what is commonly used within the engineering space. It's very expressive. and it gives us the ability to model, diagram, and show all the connections between various parts of the model. Sometimes those connections can't even be expressed in some of the representations directly, but they're implied, and but we can model all of that. And we can define all of our terms. We have a full glossary. We talk about things like, devices, parts, the components, configuration, and we also talk about all the things that we can observe in that device. We also model things that are used within the manufacturing process, the assets, things like cutting tools, raw materials, QIF inspection reports, all that kind of stuff. We model. Actually, we just extended it into parts and processes. There's a ton of stuff out there. And we also describe things like the machine's capabilities, kinematics, geometry, which I'll show you a little bit later, that can be provided as the specifications. And again, we have open source reference implementations and tools that allow you to do, to work with the standard, to play around with it, to create your own configurations. And we'll be demoing some of that stuff later. So a model is a formal language. It's a structured way of being able to represent, in our case, information and behavior. It goes beyond just, blocks and connections. It actually, you can talk about how the model is supposed to interact. And I'll show you some examples of that in a second. And it also gives you definitions and a way to define terms and associate terms and generalize terms and all those kind of things that are difficult to specify just in a document. And we can also create various projections of the model into different representations, such as XML and JSON or OPC UA or whatever, or even SparkPlot-B. We can project the model into various different representations, which allows us to extract ourselves from any arguments or any of the protocol wars. So basically, we're neutral. And of course, our model is never going to be perfect. It is continuously evolving. And George Box once said, "All models are flawed, but some are useful." MTConnect is a useful model. And we're continually making it better. That's the role of the MTConnect Institute and the Standards Committee. And it's been, I think, getting better for the last 17 years. To show you what a model is, this is sort of a standard concept of what you see as in the information side of it, where you have things that are connected to other things, right? And the named relationships, all these pieces are defined, all the properties are defined. We can put constraints on things like multiplicity. We can even get down to constraining it even more and talking about, how like a device is supposed to have certain observations or certain data items associated with it and how those observations are made and so forth. So there's a lot that is built into the model that describes how it works and what the relationships are. We can go beyond that though in the model. We can go into things like defining certain protocols, like how are things supposed to interact with each other. This is, for the inter-device connectivity. So we can define, complex, what are called activity diagrams, which show how communication is supposed to occur. We can also create what are called state machines, which show for certain parts of the standard, like in the inter-device communication, what the different states are and how those states are related and what the transitions between them are. A model also allows us to do what are called use cases. We can define in the model itself what is required to do a certain types of things. So here's a manufacturing equipment. We're monitoring operations. For machine monitoring, what pieces of the model are required? We have a use case down there, and and what parts of the model are required to participate in that. So it goes way beyond just pure information. The model allows us to express complex relationships, behavior, and such. That's also what makes MTConnect special. is this idea that we have moved away from, this is the way I'm going to just represent the model and communicate it, to here's how the model works. And we have defined how these representations and how these protocols work, but we can also now support anything else that's going to come along. So we've future-proofed ourselves. We've made it so that we can project out into whatever new standards are going to be available in the market. And all of our technology is open source, royalty free, open IP for the standard, the model, as well as the implementations. And we have all these tools. And as well, mention it again, we are ANSI accredited, which means that we are recognized as a standard by the American National Standards Institute. So basically, we are a standard. We're also international. And eventually, we'll probably be pursuing international standards recognition as well. So people will often ask us about other standards. Like, the biggest one is, of course, OPC UA. But people ask us about things like, how do you relate to things like MQTT, Sparkplug-B, and all the other standards that are out there. A lot of these are communication standards, bus standards, and so forth. So if you think about it, MTConnect is a domain model, provides a viewpoint from the machine up here. It can use any of these protocols to and information exchange process mechanisms to communicate itself. Like the beginning, we started with just REST. So we had MTConnect, we had a REST protocol, which uses HTTP or REST information exchange service, which used HTTP as a protocol, and we could have representations in XML and JSON. We still have what's called normative standardized way of doing this. It's in the model. Actually, the whole HTTP protocol is in the model, as well as the REST interface that we present to the outside world. We also have a companion spec in OPC UA, so we can use OPC UA, and we can project ourselves as an OPC UA node set as a representation. And there's also a JSON representation of that, which OPC UA supports. So we go this path as well. This is perfectly fine. And it is normative. Sorry, I just clicked on the wrong button. We also are developing a companion spec with Sparkplug-B. Sparkplug-B uses MQTT, and the representation for that is protobuf. So we can project ourselves this way too, using the Sparkplug-B standard. We also support MQTT directly using a JSON representation. We have two different implementations of that now. There's one that is now recommended by the standard and is supported by the agent, and we're going to make that a normative part of the standard. But basically, we can just use MQTT down that stack. So MTConnect can project itself in multiple different ways, and we document all these representations. If another protocol comes along, we can support that as well. But anyway, so that's kind of where we layer ourselves. We are a model that sits on top of all of this stuff and provides ways of communication and representation that adhere strictly to our definitions, our structure, and what we have in the MTConnect model. Now, how does it work? Basically, from any client machine, you can have your software out there, your application on this side. It's going to make requests of the MTConnect agent, basically just HTTP requests if it's using the REST protocol. And the machine is going to respond with a response. A little bit about REST, it's stateless, meaning that the agent doesn't keep state. It's client's responsibility. We'll dig deeper into some of the nuances of the REST protocol, but basically we just make requests, samples, current, probe sample current, and that gives us the data about the machine. Most implementations, I'll go into more detail on this in a minute, there's an adapter, and the agent talks to the adapter. The adapter translates from the machine-specific APIs and proprietary methods to a common intermediary format, which is actually it's not standardized, but it's part of the reference implementation. There's piped limited key value pairs, and that goes to the agent, which then again goes to the machine. One fun thing you can do, actually, you can even try this now. We have a demo agent that's always running out there, demo.mtconnect.org, and you can basically get data directly from the agent. And we have a style sheet which formats it. I'll show this in a minute. And yeah, it's not an application. You can use it for testing if you want to see, okay, is my agent responding correctly? And it is basically behind the scenes. This is all just XML. And you can do XML or JSON. And yeah, it's cool. You can also do things like getting the entire REST API using Swagger, which is asking for Swagger. So the REST protocol that was created and is now 17 years old, hasn't changed a huge amount, is a probe. This returns you all the metadata about the device. So this same is in the device file, but basically returns all the metadata. A current gives you a snapshot of all of the data at a certain point in time. So this gives you every single observation that is made right now. And you can also give it a path parameter. So if you don't want all the data, you can say, just give me, let's say what's in the controller. Or you can say, give me just the telemetry from the machine. I'm only interested in the path, and sorry, in the positions from the various different axes. So I can do that. And I can do that for the sample too. Sample returns a time series set of data from the machine. So where current gives you a snapshot of everything, a sample gives you all of the changes. Again, this is sometimes called report on exception, but it gives you just the deltas that have occurred from a certain point in time. And we do buffer data. So we're able to give you a time series, and you can collect that data at whatever frequency you want. So you don't have to, be collecting all the time. You can, pause for a second or so and then go and grab more data. We also have two ways now of pushing data to the client. We have both WebSockets support now in the agent, the latest versions, as well as what's called long poll, which is an old way of doing an XPoll, multi-part replace, which basically just keeps sending you data basically ad infinitum. So you can do currents, which give you snapshots. You can also have it continually at a certain interval give you more snapshots. So I can say, just give me snapshots every second. I can say, give me a snapshot. Remember where that point in the buffer is, and there'll be a lot more detail on that. And then give me all the changes that happen beyond that. We can also get a sort of a key value pair set of data coming out of the agent, which is called the assets. And that tells you about things like, what are the tools? What are the files? I can get process data now. I can get parts data, 2.7, get all that kind of fun stuff. So what is it that we can get? So we have a lot of data that we can collect in MTConnect. We have our conditions, which allow you to get sometimes called alarms, which tell you about, for each of the components, they can tell you things like, over travel, or we have system alarms, general alarms. We have, any data item can be an alarm. So you can have like a temperature condition that's associated with the temperature being measured from a motor. So you have a sensor on the motor that's measuring the temperature. If the temperature goes over a certain temperature, it raises a condition. Conditions are 3 states: normal, warning, and fault. Normal means everything's okay. Warning means we're starting to get to a possible fault situation. Fault is something that needs to be corrected by probably some intervention by a human. We have all the axes data, things like positions, velocities, feed rates, loads. There's a ton of just basic axes data you can get. Use spindles, which are called rotary axes in a spindle mode. We can get, again, things like loads, RPMs, which is a rotational velocity, and a bunch of other stuff, again, from your spindles. We have a lot of different things we call systems in MTConnect. Those are things like you have hydraulic systems, pneumatic, electrical. They're things that are sort of across the entire machine. So you think about a hydraulic system, it's not just in like one point. You have hydraulics that go all over the place. You have pneumatics that go all over the place. Electrical, of course, everything is collected to connect to some kind of electrical system. And there are certain things about that. You can get the voltage, the current, you can get, temperatures of an amplifier, all those kind of things from your electrical systems. Coolant systems, again, filters, coolant flow, concentrations, all that kind of stuff associated with your coolant system. Controller has a lot of the information that is relevant to your control systems, things like what program's currently running, how many parts have I made, overrides. We have a whole bunch of these things called control vocabularies. They're basically a set of enumerations or states. So things like your mode and execution have certain states. They must have certain states. They cannot have other states. Things like automatic manual MDI. We have a lot of different modes the machine can be in, as well as execution states. These are very important because for an application to be able to interpret what the current mode and execution state of the machine are, those have to be locked down. We also have, these are interfaces, things like, robot and bar feeder interface, and so forth. Controllers can also be broken down into paths. So if your machine is capable of running multiple different paths at the same time, you'll have the controller, which has some high-level stuff, and then below that, you'll find each of the individual paths for like 2 different spindles. Your headstock and your tailstock will be called out. And then we have a bunch of other stuff, tooling interfaces. We can do data sets now of all the variables, additive, parts, pallets, fixtures, etc. So there's a lot of different information you can collect. And we'll be going into much more detail around these things in the upcoming sessions. So data transport, basically, if you think about it in abstraction, you have the MTConnect, you have the machines out there with an agent. Agents can run for multiple different machines. So you can have one agent that supports one or more machines. Data formats coming out, whether it's XML, JSON, node set. We can use different transport, HTTPS. We now support secure sockets as well, even with dual security, OPC UA, MQTT. Whatever your machine, the idea was behind MTConnect, we're a model. Whatever makes it easiest for your application to consume, we want to be able to support that. If your application, let's say, supports OPC UA, we'll give you OPC UA. If HTTP is good for you, we'll give you REST. If MQTT is what you like, we'll give you MTQTT. So basically, MTConnect will support whatever, like in UNS, if it's MQTT, we'll give you that line as well. So what can you do with it? There are tons of different use cases for MTConnect. We'll go through sort of a progression of these later, but real-time dashboards. Of course, you want to be able to see what's happening on your shop floor. You want to see the machine statuses. You want to be able to monitor your utilization, how much your machine is being used. You want to be able to do things like, giving an OEE metric, but a real OEE metric that tells you, not just, availability, but also we want to be able to measure things like good parts and bad parts and measurements, metrology, and so forth. And of course, sometimes that requires operator involvement, but there's ways of being able to do a full OEE, even a performance measurement based on sort of a golden run of your process. So I want to be able to measure how does every process stand up to my best run of this process on this machine. I can measure that, and I can do real OEE with MTConnect. Then I can do get into things like preemptive maintenance, log, temperatures, loads, vibration, coolant levels, pH. We can measure all that stuff in MTConnect through sensors. And then how can I start looking for signals that are now associative with something that has gone wrong in the machine? So can I start to see when these various different measurements coming from the machine or observations coming from the machine are indicative of something that I probably want to deal with? I can even do, the simple form of that is, of course, use-based maintenance. So how much has a machine been used? That will tell me how, when I need to start doing some maintenance operations on it. So maintenance is one area that MTConnect can really help support, as well as things like, tool management. I can tell exactly how much my tools have been used, which tool is being used. I can get down to the asset data. I can get down to offsets and my tooling measurements. Now we have in support, we have automation. And I talked a little bit about this before, but we can connect multiple different machines together by allowing machines to observe each other. Things like we proved this out back, actually 1.3 is going back to 2011. We had a bar feeder, a robot. Yeah, we had a bar feeder connected to a machine tool and a robot connected to a machine tool. And we were able to allow those to interoperate, interconnect by just observing their different states and what they need. That has now been extended way beyond that to task coordination, which we now have in 2.7. That's currently in review. And that allows us to allow multiple different machines to tell what they need to have done and then intercoordinate those operations based on their machines, on the machine's capabilities. Somebody's actually now created a product out of that. So a lot more to come on this. We'll probably have to do another session on that, but this is a really exciting part of MTConnect. The parts, the processes, describing the parts, the processes, and the tasks that need to be done. Sort of a three-legged stool to doing automation. But it's automation without a centralized control system. It's federated control. So stand by. We'll probably be doing another boot camp on just that area. For things like additive, robots, variables, data sets, and all that kind of stuff, we added that on 1.5, as well as, we got into things like specifications and kinematics. I'll show you a little bit of this in a little bit of a live demo that I'll do in a few minutes. Basically, we were able to describe the machine, all of its connections between components, as well as all the kinematics. Those are out there if you want to take a look. That's a demo that mtconnect.org has all of that data in there. It tells you a lot about how the machine is put together, and as well allows you to create a visualization of the machine. So we have that capability in MTConnect right now if you fill in all the blanks. We added metrology, basically just to throw it to QIF. We support QIF as one of the asset models that you can provide through MTConnect. So this connect to a CMM. We can collect the CMM states as well as then publish the data coming off of that CMM. The simple one, real-time dashboards. This is a very basic dashboard that allows you to see what's going on in different machines and see its different states, stopped, active, ready, whatever. So this kind of, your simple dashboards with, just some basic variables. This goes across any machine, very simple. Interesting thing is, this is actually going way, way back. They noticed that even just providing visualization of what's going on the shop floor can give you about a 10% boost in productivity. Just a knowledge of what's happening. This was shown in cars, when they put the fuel efficiency metrics in there, but this is just very basic. You can get into things like utilization for each of these different machines. What is the production efficiency of the machine? This is based on, scheduled time versus downtime. And so these are, this is one of the basic inputs to OEE. What is your production efficiency? How much time were you actually running versus the time that you were planned to be running? So, put your shop hours in, measure how much your time machine was actually in an active state with like the spindle spinning. Could be an example of how you calculate that metric. So if we talk about like what's required for like an OEE, and this statement is correct. I mean, most machines don't provide everything you need for OEE, and the reason is they don't provide like, let's say, good part, bad part. Some of that you can actually infer from like, whether the machine completed the program successfully. So, we can get it. Some machines even have good part, bad part counts, but if you get all this stuff from the machine, combine it with your production schedules, downtime reasons, and inspection results, you can actually get a pretty decent OEE metric coming out of your shop, if that's your goal. And a lot of what this is sort of a diminishing returns. So it's sort of the Pareto 80-20 rule. For a little bit of money, you can get a lot of value. You can get a lot of bang for your buck just by visualizing and calculating your unit utilization. Doesn't cost you a lot, gives you a lot to just get started. Going to OEE or predictive and prescriptive costs you more money. I think I'm not sure if this is actually true. I think this sort of, as you get to OEE, you get diminishing returns, but I think there's a big bump. This is sort of a prior slide. Probably should have edited it, but I think there's a lot you can get out right now out of going to some of the, I think we're getting closer to being able to get that big value add from prescriptive and predictive analytics. But just be aware that even if you spend a little bit of money and go here, you'll get a lot of ROI. Basically, this thing will pay for itself very, very quickly, regardless of the app you pick. Any of the apps will give you that big bang for your buck. From a maintenance perspective, we can add additional sensors in there, like coolant sensors, pH sensors. Those are, one simple way of being able to say things like, do I need to add coolant? Prevent pump failures? Is my temperature, the coolant temperature correct? Could affect quality. Same thing with things like pH, concentrations, tool life, process stability, all these thermal growth. So make sure that the coolant isn't too warm, which could then affect its ability to be able to cool the tooling and the part correctly. So basically, simple things like you stick a coolant sensor in and suddenly you get all of these maintenance capabilities, spindle temperature, vibrations, will start to give you signals that maybe something's going wrong with my spindle. Same thing for rotor, your axes. Are they in spec? Am I getting an over temp warning on my spindle, which could mean that, let's say, my feed is too high. So maybe it's process variables. Maybe maybe one of these motors needs to be maintained or fixed or lubricated because I'm starting to see one of these signals. So anyway, maintenance is a big area that data collection can really affect for the positive. Measurement, of course, these are all the QIF standards out here, the rules, plans, execution, results. A lot of what MTConnect deals with is this results piece right there. I measure my part, I get my results out. I can then transport that XML document from QIF using MTConnect. We can also do in-process metrology, so mapping from in-process measurement on the machine tool itself to QIF and then out using that standard. That's a very powerful capability within MTConnect to be able to support not just measurements from the machine directly as it's in process, but also while it's measuring as well. And we were thinking about doing our own standards for this, but then we found QIF, and actually we have the ability to do things like feature measurements within MTConnect itself, which could then feed into another system, which then could create a QIF results report. The feature measurement part of MTConnect was done in concert with QIF, so it's meant to work with that standard. So we've taken a lot of vocabulary that comes out around features and characteristics that are part of QIF, mapped them into MTConnect, and we're just using that vocabulary to talk about what's going on in the manufacturing process. It gives us also a placeholder for things like doing feature-based association. So what feature is my machine tool making now? We can represent, if we can get that information out of the machine or infer it from the machine, we have now a way in MTConnect to be able to present that information that is part of the standard. One exciting piece that's come out recently, this is actually in the current release that's under review, is parts and process data. We've been working on it for years, but it allows us to tell what process is being executed at the machine, things like, start times, materials, all your process information, all of the operations, what assets are associated with those. So like I have an operation that's going on, what tool is associated with that operation. They're called activities. All of the processes that need to be taking place. So now we have tasks. So there's manual process or automated processes. We can now talk about those things. We can tie into the job information, the customer information. We can represent all the part data. So what part is it serialized? We can associate that part with a file, let's say the AP242 step model that's associated with it, or a 3D PDF, and represent that as a file that's associated within MTConnect. We can also associate within the process data these process events, so things that occurred during the making of that part. We have this ability to sort of associate that in that record of data. Any, let's say, conditions or overrides or changes to the process that need to be made, we can get that stuff out. So MTConnect now supports full parts and process. We want to extend that model. We sort of did a simple model for this go round. That's going to get more interesting, as well as our tasks model, which is for inter-device communication. So we have all these new pieces, and yeah, I really encourage you, if you want to take a look at it, to get involved. Join the SC. You can then get access to all that stuff.
Well, I think we're right at the top of the hour. You've done a great job of keeping us on time, and I think this "How do I get started" is a perfect break point for us to take our break. Thank you so much for everyone attending. We've got almost 100% attendance for people that were registered. That's amazing. Will's given you a lot of information in the first hour. If you have questions or comments, please use the chat function in the meeting. We're monitoring that and answering them in real time, and we can also use some of our extra time to talk about those firsthand and give you guys your answers. So let's take about a 5 or 10 minute break. It's just short of the hour now, so let's come back at 10:10 Eastern time. So take a 10-minute break, grab your cup of coffee, and then we'll get into how do you get started with MTConnect. And Will, thank you very much for a great first hour.
Thank you, Mike. And yeah, I'll be on soon. Yeah. And Ted, yes, I think you'll be actually one of the ones who will be presenting for the robotics. Yeah, I think everybody will be pretty excited about that. It's a new way of thinking about automation.
So one quick comment I want to make before we break. All of the cool stuff that Will has talked about and all the different things that we've implemented in all the different versions of this standard since its beginning. Unfortunately, the only weak link in this chain is that some of the OEMs have not kept up and stayed current with the standard. So those of you that are here as an end user or a consumer of this data, we need you guys to lobby with your OEMs, your builders, to stay current. And I'm not going to name names here, but there are several builders who have done a phenomenal job of staying current and offering their end users all the data functions that we've added over the years. And then we have others who are stuck at 1.2, 1.3, and they consider that good enough. Obviously, when you look at the list that Will's gone over this morning, it's not good enough to offer someone 1.2 when 2.4, 2.5, 2.6, and now 2.7 is going to give you all this extra data. But it does require the builders to help allow us to get that data out of the CNC control and out of the machines. So we'll talk about that more in the later issues. So let's give everybody a 10-minute break, and we'll see you at 10:10 or whatever time zone you're in. Take care. Welcome back, everyone. We finished our 10-minute break, and just to remind everyone once again, please, if you have questions, use our chat function. We are responding to those in real time as best we can, and if we have some specific ones at the end that we want Will to talk about or that we need more discussions on, we will be bringing those up at the end of the meeting. Right now, we're in good shape. We've kind of answered most of the questions along the way. No one's had any real deep dives that we needed to talk about in detail at this point, but we will be talking more about validation and what's to come in the later sessions of this week. So with that, I'll turn it back over to Will.
Yeah, I just want to respond to one quick question that I saw coming through by Scott Miller. Yeah, we are using Cameo. The XMI that Cameo creates, which is a standard for the SysML or for actually any of the UML brand standards or information models to be represented. We're using the XMI representation, which is what Cameo generates. So it's pretty much industry standard. It can be imported into any of the other tools like Sparks or anything else. The only thing sometimes you have to futz with are the diagrams, but the rest of it, basically all the model and everything else is normative and will come out as you expect. So, but we found that Cameo was the best tool out there. And we are using now Cameo Collaborator to be able to interact and manage the model between multiple different people. So if, we can even get additional people helping out with that. So given that, that's hopefully answers that question. So here. So we want to walk through a little bit of what it is to get going with MTConnect and what the steps are. So this is fairly standard for doing any process improvement or productivity goals. The first thing is you need to do a factory review. You need to understand exactly what kind of equipment you have, where your target initial machines are. It's good to start out with a use case. What do I want to do with whatever implementation to be able to get as much value as possible? So you set expectations, set your productivity goals, and target some initial machines. Don't try to do everything at once. Usually that can take a lot of time and delay your return on investment, but find some high value pieces of equipment, some high value processes, target those machines, review your networking and security requirements on your floor, depending on what kind of an industry you're in, whether you're doing defense or commercial, for instance. Those requirements may be very different. Then you need to find a software client provider. There's a lot of vendors out there for client software that uses MTConnect, and you can even build in-house. We have a number of different implementations that have been done by corporations of multiple different sizes that have developed their own software. Or there's a lot of vendors out there with pre-canned software, and that's your easiest path to go because developing software is difficult. And then implementation. So for the factory review, so what machines produce the most revenue for you, which processes, and which machines are easiest to connect up? So we have some machines that come with MTConnect already on them, and I'll show you that in a second. And often these are some of your newest machines. So, definitely older machines are going to be harder to connect up. The ones that don't even have like a port on them of any sense. And to your brand new machines that may already have a network connection, may already have an API. So, and that includes like any machine, like with a modern focus control or hide and hide or anything like that. We can also support non-CNC machines, grinders, manual mills. We also have done a lot of work in thermal processes and things like autoclave and so forth. We have full support with that for those kind of things in MTConnect. So often that's just a set of sensor data, but with like autoclave, you can get to valve states and a whole bunch of other fun stuff. So we support all that stuff now. And then we have your older legacy equipment, and we'll talk about that in a second. So we think about the different categories. This is like a machine that you buy, and it's basically ready to go. You plug an Ethernet cord cable into it. You know the port that the agent is running on, and you're getting data from it. There's an agent and adapter or an agent already built into that machine. So there's a few vendors out there, quite a few, that have solutions, and that means, just pick your application, start getting data. There are some machines out there that only have what are called adapters. In other words, they haven't yet gone to the point of installing the agent on the machine itself. But the machine does have an adapter. It is producing what is called shutter data format. I think in one of the future sessions, we'll be covering that. And that's just timestamp pipe to limited data. And it could either be in the shutter format. We also now support ingest from the agent in MQTT. You sometimes have to do a little bit of a transform because there's no like standardized way that MQTT data is going to be coming over. So again, place JSON blob. There's actually a way the MTConnect agent knows how to recognize MQTT data if it's coming over in a certain format. So we do support a certain ingest, but we can actually support almost anything. And I'm going to be covering extensibility of the agent in these talks, but that is also a subject for a future talk. So that data, once we get it, you get the Shutter MQTT data coming in here, and then MTConnect data goes out the other end. Again, your application can consume it. You're all done. Let's continue on. The next case is where we have a machine that has a network API. A lot of these types of machines, you have like, FANUC Focus. You buy a machine with FANUC Focus on it. It has the Ethernet port. It produces, FANUC Focus 2 data. There are adapters either you can buy or are sold that support that. Same thing with OPC UA. We can ingest OPC UA data through an adapter, or actually the agent through plugins to handle the mapping of that data to MTConnect. So there's some transformations that need to occur, like on some of the states and so forth. But there's even some open source reference versions of the FANUC Focus adapter that are out there that you can play around with if you want to. Hide and Hide uses a protocol called LSV2, again, networked. There's some adapters out there that do that. So basically, for these types of things, you can either buy your adapter that speaks that proprietary, uses that proprietary API to communicate with the machine. And that adapter usually will be running off machine, so it won't be running on the machine itself. It'll be running on a box somewhere between the application, on the same network between the application and the machine tool. So you can run this either on an edge device, you can run anywhere in the network, and it will communicate directly to your application. The next type of machine is the legacy machine. So these are like your older machines. Let's say they don't even have a RS-232 port, or they do have an RS-232 port, but that's being used right now for like a DNC, transmitting programs to the machine. So it's not really usable for anything. You can attach sensors, like a sensor unit or a small, like I did an implementation a long time ago with an Arduino. You can then connect that to the various different terminal blocks in the machine. I'm talking about a machine, let's say, from the 80s. And those relays will then send you the basic states of the machine. So those are probably your modes, your stack light, your execution states, whether it's ready or active, those kind of things. And that's what, so we can support anything going all the way back to, manual machines by just sticking a little box next to it and monitoring certain states of the machine. Can't get as detailed data, you can't get telemetry and things like that very easily, but basically you can get information. The agent itself is actually capable of taking multiple different feeds of data at the same time. So you can have data coming from the controller, you can have an additional sensor unit, all of that can feed into the agent, and the agent can then consume and combine, synthesize that data together to create a singular view of that machine at a certain point in time. So, that's one of the capabilities of the machine of MTConnect that was built in there very early, was this idea of sensor fusion. The idea that we need to have multiple different feeds coming in to represent the true state of that machine. So the next state is, so then once you understand what kind of machines you have in your shop, whether it's something simple, buy a new machine, already has MTConnect, good to go. Need to just put an agent out there and attach it to the adapter, or you need to do an agent adapter combination, maybe buy an adapter from a third party, or get it from the machine tool vendor itself, or deal with some older legacy machines. Usually for an initial pilot, you'll be in either this situation or this situation or this. Basically, start, if you have these machines, with the ones that are ready to go. That's going to be your best bet to get started really easily, show some initial value, plug it in, just go. So, maybe that's not the best place to start, but basically choose your initial machines, your ones that are capable, plug me in, get going, and then, find out if there's anything that's like hardware upgrades or software upgrades. Sometimes that's required to run MTConnect. And then start collecting data. And again, you can start up simple. You can go, engage with a application vendor who can then get you started and start getting your value flowing in. One of the things that often we need to consider, and this is something that, having done a lot of these projects with companies in my past, often you'll walk out to a shop floor and they don't even have networking on the shop floor. And then you're stuck scratching your head, like, okay, how do we get started? So the first thing that you want to do is also make sure that you have your machines networked in some way, or that you can run cables to those machines. One of the things that people say, can I use wireless? Yes, in certain cases. One of the problems that we found with wireless is if you have things like welding or EDM equipment, or even some additive equipment, sometimes those produce a lot of RF, radio frequency noise, that causes your wireless to go out. So basically you'll be collecting data, everything will look great, and then somebody turns on the EDM and oops, I've just lost all my connectivity. So be careful with wireless. It can be an issue. So just make sure that you run enough tests, you have enough wireless. You can use like a mesh network and make sure you have enough access points that you can get this working. Depends on the bit. This question here, should I isolate my machine on the network? That's a question you got to answer based on the type of manufacturing that you're doing. Sometimes you care, sometimes you don't. From safety reasons, you don't want viruses or things like that getting into your machine. One thing that MTConnect does provide, because we can do things like this, where we can sit actually in between on a device that shields this machine from the rest of the network. So basically your machine can just connect to the adapter, and this can be done on like a switch. You put a switch here, and only the adapter can talk to the machine. Only this device here can talk to the machine. You can then restrict all other communication to this device only on the outgoing port of the agent. So only the agent can talk to the application. This device can talk to here. So basically you have, in a sense, a firewall here that protects that machine from the outside world, but gives you the ability to still get all the data you need from the machine. Some of the new capabilities in MTConnect also around things like files and such, you could actually use it by putting a DNC application on that box as well, send your files over, and then the machine can get access to those. Again, you can isolate that one part of your network from all other activities. So that's something you could think about too. Do you want to put a switch, a smart switch, or a smart device next to your machine that will isolate that traffic? And then it's, do you want to connect to your business network? That's another decision you need to make. How you want to connect it, how you want to lay out that, architect your network to ensure safety and security. And this all depends on what your security requirements are. If you're doing something like CMMC, you may want to slap on some more security. Again, MTConnect provides secure sockets communication, HTTPS. We also support dual certification right now. We're looking for more people to help us with some of our security requirements. So, do we need additional layers of security in MTConnect? Maybe. In the reference implementation, we can do that. Currently, we have supported what our community has asked for, but we're definitely open to more suggestions on this point here. So your networking, first off, work with your IT department, make sure everything's ready to go. That can be a blocker. We've seen it before, but just make sure that you are in good shape for that. A couple of different ways we can go here. We can do internal solutions. Basically, within your factory, you have your application, you have your servers, you collect data. Everything is done within a hosted environment on-prem. So you can do complete on-prem solutions where your application, your network, your database, everything else is managed locally. And whatever, either you develop your own applications or your team is required for sort of managing the communications and managing that application and that server. So they're required to manage that hardware. The other option is you can go for like a cloud solution, so vendor supplied. So basically, you are just collecting your data, but you send it up to the cloud. And the vendor then basically hosts your application for you. You are responsible for your network and your infrastructure for collecting the data. The vendor then is responsible for the database and the server and maintaining all of these services for you. So this is basically where you take your local operation, you move it to the cloud, and allow that vendor to give you sort of a managed solution for you. That's option number 2. Option number 3 is a complete sort of hosted solution. So this is these are like examples of cloud solutions where the factory is responsible for sending data to the internet. And basically all you're responsible for here is just sending your data up, and everything is taken care of for you. These are usually multi-tenant applications, meaning they're dealing with more than one user at a time, and they are complete managed services. Through economies of scale, you can sometimes get different cost structure, on a internal solution versus a vendor supplied solution versus a remote solution, because basically here in these types of things they're combining a whole bunch of customers into the same application um, infrastructure. So it's using the same set of machines, effectively, or virtual machines to run the app, which means that it's a little bit lower. They're amortizing cost across everybody. But anyway, there are security concerns. There are, requirements, regulations, and so forth, which will guide your solution, your choice of solution. So choosing the vendor. What connectivity do they provide? So do they only provide, for existing machines? Do they have their own adapter libraries, or do they, what application, what, machines do they support? Do they support my set of machines, or do they know how to connect those set of machines that I have on my shop? And can they deploy the way I want them to, or the way I need them to? Are they only cloud? Are they managed? Can they, let's say, give me an instance on the Gov Cloud? Do they support, or do I want to have something, let's say, that is just a cloud solution, good enough? And, do they support my price point? And then what type of features do they have? Do they give me, real-time dashboards? Do they give me charting? Do they do maintenance? Do they do any predictive stuff? Do they, what kind of reporting and information feedback can I get out of this app? Can I do my own? Do they have an API? Can I get my data and do my own analysis of it? So I want to be able to answer all of those questions. Can I do what I need to do to run my shop, to run my business off of what this application provides me? And then do they integrate with my existing, this is ERP, but also MES, PLM, whatever systems that I have? Do they provide an integration point with those? Yes or no? So, we want to make sure that the solution you provide that's provided gives you the connectivity, gives you that sort of business integration value that allows you to do more with data. So, what part am I making right now? Well, how can I check that with the part that I'm supposed to be making? What are my predicted cycle times? What are all those kind of things? So, do they provide all that capability? Do they provide tooling information, tooling capabilities? A lot of different things, questions you want to ask of that vendor to know exactly what they provide you and whether they meet your needs, and also meet your needs for where you want to go in the future. So you may not start with this, but then you will, you want to make sure they can go where you want to go. At this point, I was going to just take a quick break and just show you a little bit of stuff. I was going to show you just a little bit about how the MTConnect agent works, and then we'll get back into some other things. Let me just to show you how easy this thing is, there's a different window here, so you know how to get started with it. This is actually a public server that we run called demo.mtconnect.org. I'm just doing a probe here, and you can see all the data. So when you get a machine that supports MTConnect, they'll probably give you something where you can just hit the machine directly. If you change this with the IP address or the name and the port, it will give you all of the information about the machine. And this is actually just XML behind the scenes. It's just a transform. So it looks kind of pretty. Somebody did a nice style sheet for us, and we really appreciate that. The idea behind this is with REST, you can just make a request and find out, like, okay, how's this machine put together? What are all the components? Like, here are all, some of the structure, solid model pieces of it, the axes, the x-axis, some of the specifications about that, linear force, velocities, and so forth, what our relationships are to our other pieces of the machine. Then you can see certain data items like, positions, samples, so forth, and velocities, and, loads, linear forces on, this is the z-axis. So we have a lot of stuff here. So rotary axes, speed, overrides, modes, etc. And velocities and program overrides, all that kind of stuff. So everything, as you can see with the types, are laid out. These are the types. These are according to the standard. So all of the type information here, positions, load, revolute, rotary velocity, rotary mode, all this stuff is according to the standard. When you see things like extensions here, these are extended vocabulary. So this is some additional information that they're providing that is not in the standard, but you can extend it. So MTConnect is an extensible standard. Everything that doesn't prefixed, that's part of the standard. Yeah, so basically you can just look through it. You can get a current from the machine as well. Looks like this. This gives you the current snapshot of all the data at a certain point in time. And one thing to look at, this is the next sequence number. If I do a sample, I can get all the data, but if I put that number in there, I basically get the sample at that point going forward. So starting at the sequence number, I get all the samples from that point onward. And that allows me to work my way through the buffer. And we'll be demoing this in much more detail, just to give a flavor. The back end of this thing, we want to take a look at what the actual XML looks like. Second. There we go. And let me just get that window up there. So in back of this, we have a style sheet. That's what's doing the pretty printing. And as you can see, we have all of the data here. This is actually according to the standard. So if I was to do like a probe, we'd see the other set of data. So this is what it looks like in its raw format. So I just wanted to show you that when you get MTConnect running, this is just something you can play around with. I want to, it's sort of a nice feature of using REST as the underlying protocol for MTConnect, which is actually required by the standard. Oops, there's the wrong thing, to exist on any agent implementation that we have. So any agent that's compliant with the standard will provide that capability of being able to just interrogate the machine for its data. So yeah, if you want to check it out, just go to that link right there, demo.mtconnect.org, and this link right here, and that will take you to it. Yeah, just sorry, one other thing I wanted to quickly show you that's also up there if you want to take a look at it. Jump right back to here. There's a couple of little links here. You didn't notice Mazak Digital Twin and the Akuma Digital Twin. So we have two machines that we built these for a show. And this is actually, there's nothing in what I'm doing here. This is just some JavaScript that's going off of nothing but the data that is given through MTConnect. So there is no additional information needed outside the MTConnect standard to make this work, except for like the solid models, but those are just OBJ files with basically all the motion, the connectivity, the kinematics, everything else are provided within MTConnect model. So just FYI, there's that guy. And then we got this guy over here, which is an Akuma machine. It's a Milturn, obviously, with a head and a tailstock. Right now it's working on the tailstock. And you can see some of the data here. and you can see it moving around. So that's pretty much the same thing. We've got 2 machines up there. All this code is open source, and it can be run through, if you're familiar with Docker, you can spin up your own container with it, or you can just kind of poke around here. You can download if you're into JavaScript, you can download the code and play. Let me get back to, that was like a brief segue into some of the stuff that you can do just with the agent. So, fun things. So, let's get back to implementation. So you got your agent, you can poke at it as we just saw. Now you want to start your implementation. So the idea is to start easy, crawl, utilization dashboards. Just when are my machines running? Are they running? What's their productivity? Are they actually running when they're supposed to be running? You can do like a simple availability analysis, which is basically, hey, my machine's supposed to be running for, 8 hours a day, let's say, one shift. Are they, what percentage of that time are they actually being utilized? Next, you can get into dashboarding that. So, you dashboard that, put it up in your shop. Now you can sort of see, when the machines, how much the machines are running. Those are some really low-hanging fruit. They're very easy. With the MTConnect standard, with only a few data items, like controller mode, execution, if you want to get fancy, rotary velocity from your spindle, you can actually get a really nice metric when your spindle's spinning and when your machines are actively running a program. Of course, then you can, once you have some basics done like that, then you can go into the walk mode, which is basically you can start doing some analysis on that. Like, how much of that time that they were scheduled to be running were they actually running, getting operators to give you feedback. So when the machine is scheduled to be running, it's not running, have the operator give you some reasons why. That's most applications support something along that line. The idea is your machines are telling you what they know about themselves. Often what this becomes is not a way for management to beat up operators, but for an operator to say, look at what's happening to this machine. It keeps erroring out. It keeps failing. There's something wrong with it. I'm waiting, or let's say I'm waiting for maintenance. The machine is down when it's supposed to be running. I'm waiting for maintenance. Maintenance hasn't come. Maintenance says they're busy doing other things, or the parts haven't arrived from the upstream process. I'm just in a wait state. So what it often becomes is the best way for operators to provide their view of what's happening to management. It actually becomes a tool for operators, oddly enough. And then you can get into things like, preventative maintenance. This is not as hard as it seems. So you have scheduled maintenance, basically on fail maintenance, like your first step. Second step, usage-based maintenance. I have been using the machine for so many hours, and now I need to maintain it. So basically, or just, maintenance on fail, then scheduled maintenance. I'm going to schedule maintenance every, let's say, 6 months for doing X, Y, and Z, which may or may not be needed. Let's say the machine hasn't been used for 6 months, or it's been used half the time for 6 months. Why do that maintenance? Could it actually cause more problems than it's worth? Next stage is use-based. Use-based maintenance, basically you schedule maintenance based on like how many spindle hours. So how long has this spindle been spinning? Then let's do it every, let's say, couple hundred hours. Next date, you do preventative. So then you can get into predictive maintenance. So that's when you start combining things like the sensor data. So I take my sensor data, I combine it with my usage data. Now I know that even if it's being used, but let's say I'm seeing temperature warnings coming up on my spindle, I probably want to do more aggressive maintenance on that. Or if I see like vibration or the machine isn't holding tolerance as it should be, all of these things will be signals back in to a preventative maintenance scheme. Next state, you get into some prescriptive. So I've done my preventative. Now I can start doing prescriptive maintenance where I can actually check to see. I have an application that tells me that this is the maintenance you should perform at this time to correct whatever problems. That's where you start getting into like, digital twins. Before we didn't have terminology for that. Now, digital twins provide that capability where you can actually simulate the machine states based on its feedback. So that's where MTConnect comes in. So in the run state, I want to say you're OE this, but yeah, so you start integrating with all your other management tools like your ERP, MES, PLM systems, tool management systems, feedback to tool management feeding back to the shop where I can get my tooling data then presented at the machine and automate things like, offsets. I can start automating various tasks like we talked about with the robotics and such, and get into those targeted improvements. So we can start taking our data that we've been getting into and getting into those prescriptive changes to our manufacturing systems through various different feedback. Again, for MTConnect, that means, again, pushing the vendors to give you more and more data. So MTConnect as a standard supports a ton of data. We have thousands of data items defined within the standard. We can definitely provide, depending on what's needed by your application, we can provide information about the process, information about the state of all the different components of the machine, as well as how those components are related to each other. As you saw the digital twins, we can even provide kinematic feedback. We can provide specifications about loads and so forth, and maximum loads, excessive loads, process specifications. We have all that in the standard. If it's implemented, you have a gold mine of data that will allow you to do a true digital twin, basically a model of the machine as it's executing that is then going to be able to predict future state by training that thing up. So that's where we want to get to. But again, start with your low-hanging fruit. Start with your connectivity, your networking, and then start getting some data out of your machine. Show value at each of these steps. There is a lot of value. You'll be surprised just by doing some simple analytics on top of your machine. You can start to understand why, let's say, the machine's not running. Downtime classification is a very important thing. Was a material missing? Was tooling missing? Did I not have a person? Was it a manpower issue? All these kind of things. We can start getting those data, getting the data in, classifying it, understanding why things are happening, giving that objective view of that machine, looking at, then MTConnect provides all this stuff. Basically, program stop, M00, M01. Were my overrides set? Did somebody set the overrides for the feed to 50%? Was my spindle override not set? Did somebody play around with that? Did that cause a tooling issue? Did that cause chatter? So I can start to look at all of this data, pair it with my outcomes, and get a real good idea of what happened within my process. And it's an objective view. It's not somebody saying, this is what I think happened then, or do I remember? It's basically, this is what the machine recorded. And then you start getting into your targeted improvements, process flows, bottlenecks, looking at where your downtimes are causing inefficiencies. You can go back to something like the goal, and find your bottlenecks, elevate the bottlenecks, and then eliminate them. But this gives you the data to do it. Cycle time, performance, not what you expected from your engineers, your CAM engineer, your process engineer said this would take, let's say, an hour, and it's been running at an hour and 15, or the other way around. They told you it was going to be running an hour, and this only takes a half hour. Why? Let's figure that one out. Let's figure out also, and the interesting one that we've seen is this concept of capacity. Do I need to replace or purchase a new machine? Or do I have enough equipment? I'm just not utilizing it as much as I should be. So sometimes, the machine tool vendors don't like to hear this, but basically, we can sometimes just work with the capacity that we have. We use it more efficiently. If I can get, let's say, 50% more efficiency out of my existing equipment by dealing with issues or understanding issues that are happening on the shop floor better, maybe I can get that additional utilization and avoid a new purchase, or purchase a new machine that has better connectivity and gives me better data analytics so I can start doing some more interesting things with it. That's another aspect. So, that's something that the machine tool builders want to hear, is that, newer machines have newer capabilities, better data analytics you can do with them, and provide a lot more information. So look at what you got on the floor, look at what you want to replace it with, and then how can you make it most effective for you. And then we start getting into automation. We're working on this area with a company right now, which is implementing it. And we did it actually for 2018. Rob and I, for the MTConnect Institute, did a demo where we did this, task integration model. Basically, automated systems that have you have cell automation. You can actually tell if there's a bottleneck in your cell or a problem in your cell. Your cell keeps erroring out. The end effector keeps dropping the part, let's say, or wrong end effector in the wrong place at the wrong time. These kind of things. Will automation help me? Is another question you need to ask. So I have a cell. I have operators that are loading the machines. Will making that cell automated, is this some task? Let's say they're just loading a bar feeder. Is that a good opportunity for automation? I can tell because of variance in the start and stop times. I can tell whether I would be better off maybe doing this as a lights out process and having that person better allocated doing some more interesting work. So there's a lot of areas where just getting this information from your machines can enable better decision making. And there's a lot of these activities. Plus now, we could even integrate with things like AGVs. If you know where something needs to be, there's a lot of work that can be done on the automation front. And that's an exciting part of the standard development that we're working on right now. So anyway, it's actually in 2.7. So, decide how you want to automate. There's a lot of automation options that are now available because of things like cobots and a whole bunch of other technologies that are out there. So, one thing, once you get all your machines connected up, is, okay, now how do we want to make best use of them? So, expectations, we can do, I think this can actually be raised as an old metric, but I think we can actually, for your automated cells, I think, maybe with some of the predictive maintenance and such, we can actually get higher than that number, but 3 to 10% on automated. Standalone machines, we can get up to 15%. We've seen, actually, going from some of my own stats, we've seen up to 30% on some shops just by being able to get better handle on why downtimes occurred, part flows, and all that kind of stuff. So when you get part data, process data integrated, I think you can get pretty decent, improvements, and then your overall factory. Again, these are conservative numbers. 20% improvement. I think you can get that pretty easily once you have your machines hooked up, and you start getting some of that data back. Again, a 20% improvement. I think you can just 10%. I think just by visualization. I think you can start. With some of the newer technologies coming out, I think you can get a lot better. So just summarize. Just about done here. Start with your factory inventory, details of your equipment, contact machine builders. Your MTConnect compliant machines, are always going to be your easiest best bet. That will get you going really fast. Start with your simple dashboards. Start with visualization. A basic utilization metric is usually a good way to get an idea of what your machines are currently doing. And then get your application. Pick an application. Either you can do it internally, or you can find a third-party app. There's a lot of third-party apps that support MTConnect right out of the box, and that will get you going really fast. And then, of course, this should be upfront. Figure out your use cases. Figure out what you want to get out of this, what you think is going to have, what's your starting goals, and where you want to eventually get. So plot that course out. Think about it. Your initial use cases, parade them out, 80-20, use, what you think you can get the biggest bang for the buck, and then where you want to go after that. And where you think, from a data collection, application perspective, what your end goals are. And also look at things, of course, like your security requirements and your networking requirements and all that kind of stuff. So that's where you need to start this process out. And almost out of time. Actually, I met the 2-hour limit because we wanted to get to the questions right after this. But these are some links that you can go after. The MTConnect.org link, that will take you to our main sort of landing page, getting started documentation. These videos, of course, are going to be posted. The itself, and I can quickly actually show you that, is at that link right there. And then the project's website, if you want to join the MTConnect Institute, it is, by the way, free to join, free to participate, and free to use any of our technologies. So basically, just go to projects, you can sign up, and there'll be basically we have to activate the account. That's just we were being spammed a bit, but once you sign up, you can effectively start participating in the working groups. We'll give you a call, we'll reach out to you, and you can be part of the standards development process. Just to give you a little for that, I'll jump back to here. And with that, after that, I will wrap up and we can go to questions. So the model, you want to browse that, is model.mtconnect.org. And it's a SysML model. Click on the structure button over here, and you can see all the bits and pieces of it. We have details about like the REST protocol, if you're interested in that, how that works. We have bits and pieces on device information model here. if you're interested in observations and so forth. And we'll be going over this in the other groups. I just wanted to show you if you're interested in perusing that. And of course, the projects site is here. And it's projects at mtconnect.org. And once you're signed up, you can start looking through all of our work. So things like machine tool working group issues, all the issues that are being worked on, all the additions to the standard and everything else. Once you're an official member of MTConnect. So those are your major links. The landing page for MTConnect is right here, of course. If you got here through that, you know about it. We have demo servers. There's a lot of third party. Oops, that needs to be filled in. There are a lot of third parties like Mazak and Stratasys have machines out there. They'll be demoed this week. And we have the standards committee information out here, which gives you top information about our meetings. And here we have all the meetings that we have currently going on and their schedules. So anyway, play around with that. So
great job,
this
Will.
is some information. Okay. So,
yeah, this was perfect timing, and we met our time goals. Take care of your time. Our second session will be starting a little bit later this afternoon. I believe it's 12:30 Eastern, 11:30 Central, so we got about a half an hour. This afternoon's, we're going to dive deeper into adapters and agents and how they work together and give you some details on that. McAllister from TAMS will be providing that session for us. And we've got, again, 2 more sessions tomorrow, getting into configuring a machine and actually querying a live machine and getting real-time data. We'll have that going tomorrow. And then Thursday is going to be a review of all the changes that have happened over the different versions, what the latest and greatest is, and what we're focusing on for the future. And following that up with a session in the afternoon about validation. In other words, how do you guarantee that your builder is giving you true MTConnect data and not providing, some garbage out there that really isn't doing you any good. So we've got a great week scheduled. We are planning on getting a questionnaire out to all the attendees about your experience. We want your feedback. This is our first effort on this part. We'd like your feedback. We'd also like to know what other specialty sessions would you like to see from us? In other words, like MQTT integration, JSON, what other functions, how to build an adapter. So we'll put some ideas together, but we'd also like your ideas back as well. Will, we've done a pretty good job on the Q&A. I don't have a whole lot here that hasn't been answered. Thanks to Trey and Neil DeRogers for jumping in and responding to people. So we're in pretty good shape on that.
Okay.
All of these sessions, these 6 sessions have been recorded. They will be we're going to put them through a little post-processing to make it easier to find the topics you may want to, instead of sitting through a 2-hour YouTube video, we're going to try to put some topics together so you can jump to different sections of the video and not waste your whole day trying to find the thing you wanted to review. Those will be published, and we will send out an email with locations and how to get to them, after we get through that post-operation once the week is over. So, So we've got a few last
we can
minute.
talk a little bit. Yeah, so go ahead. Go ahead.
Did you want to look? What were you going to say? Go ahead.
No, I said we could go through some of the question and answer if you wanted to.
Sure. Here, why don't you go through, and there's one that just came in from Jim Benson. It says, if a Mazak machine says it supports MTConnect, does that mean it has both an adapter and an agent? That phrase gets thrown around a lot in the industry. Will, you want to answer that a little bit about how do we go about determining whether I have a decent support of MTConnect?
Yeah, so you have to ask your vendor. I believe most of the current Mazaks, Mazaks going back quite a ways, have adapter agent support. It really comes down to whether the controller on the machine is capable of running both of those components. And I believe that most of the well, all the new Mazaks go. I mean, when Neil was working for Mazak, he implemented going all the way back. Even some of the ones running like Windows 98, he had an adapter on, but you had to run the agent someplace else. I think all the rest of them basically come with those components installed. Same thing, I think, with Akuma. You can get it, you can basically just install it from their app list. You go and download it, and it will run and give you, again, MTConnect.
Just a little follow-up on what
yeah.
Will just said is I've installed on both Mazak and Akuma, which are two of our biggest and best partners in the MTConnect world. Again, Neil DeRogers, who's going to be speaking tomorrow, can give you more detail, but you're right. He went back and was able to provide MTConnect data all the way back to mid-90s machines that ran Windows 95. I've actually installed it on a Windows 95 machine. What we're going to get into this afternoon, and Trey will be talking about this. There are several different ways that a builder can support it. Obviously, Will brought up the issue about an older control not having the support for running both an adapter and agent on the control. That is a true statement, but that doesn't mean that the builder can't support it. So we're going to get into that this afternoon of all the different ways that an adapter and agent can be provided to the end user. Depends on whether the control can run Windows or not, whether, you know, what the conditions are, but there is several different ways to do this, and we can go back to old equipment. A lot depends on the builder and what they can support. So I want to thank Will for the great first. We've done an awesome job of staying on time. You guys have been great. We've got a phenomenal number of people that have attended. Hope you'll join us this afternoon for the second session. And I think with that, we'll wrap it up to give people time to grab some lunch if they want to or join us in session two.
Yeah, because we have a little bit of time. I think, was it scheduled for 2 or 2.5 hours?
We're scheduled for 2.5, but I just looked at the calendar and it looks like our next one starts at 12:30 Eastern, which is only about 20 minutes from now.
Oh man.
Yeah, we didn't leave ourselves a whole lot of downtime in between. So
yeah. So I wanted to just quickly go over on the MTConnect website here. If you go to like integrators from getting started, basically you can see, you know, applications. As you can see, there's a lot of stuff out there that provide applications and controller interfaces and so forth. So, you know, there's a lot of companies out there that support MTConnect, and you should check this out. It gets us, that's part of the reason also why we have so many implementations out there, because it's fairly ubiquitous and internationally used. I mean, there's a lot of implementations also in places like India and Japan and so forth.
Sounds great.
Yeah.
All right.
Okay. Well, thank you so much for spending time with us. Hope this was useful to everybody. And
we'll see you this afternoon.
We'll let you take a little bit of a breather between these. It's really quite the marathon. Cool.
Take care, guys.
Okay.